How does one find the domain of the quotient of two functions f divided by g? Well, we kind of already went over this with the domain stuff, but remember, you're asking yourself questions: what works and what doesn't. So you want to know what the domain of the numerator and the denominator are for both of them. So for, in this example, the numerator, you want to know what works. So it's where x is greater than or equal to -4. And then the denominator, you ask where doesn't it work, and that's where x is equal to plus and minus 2. Now you take what's the intersection of these two sets. So it has to be all the numbers that are greater than -4, and then excluding -2 and 2. So as an interval notation, you can see that you get -4 closed to 2 open, or -2 open, then -2 to 2 both open, and then 2 open up to infinity. And that gives you the domain of the function. What is the composition of two functions? Well, it's where you put the output of one function into the input of the next function. So it's like two machines that are connected together. You start from the inside and work your way out. So you put whatever your initial value is, your input for g, in this case, goes in, and then whatever comes out goes into the next function, in this case f, to give you the output. How do you find the domain for the composition of two functions? Well, the key is that first you have to know the domain of g, because you want to know what that domain consists of, because only that works into g. If it's not, then it makes the machine choke and die, if you think of it like that. Now, then you have to know what comes out of g that can go into f. So that means you have to exclude the points in the domain of g that give results that can only be used in f. And that can be a little tricky, but we'll do it and everything will be fine. Alright, we're going to try this problem. So f of x is equal to 3x squared. G of x is equal to square root of x minus 5. So they say find f plus g. Now if you remember, f plus g of x is just f of x plus g of x, like this. So for our problem, f plus g of x is equal to 3x squared plus 5x minus square root of x minus 5. And if you have g, this is f minus g of x is f of x minus g of x. So f minus g of x for our example is just 3x minus square root of x minus 5. And then f times g of x is f of x times g of x. So for us, this example, we get 3x squared times the square root of x minus 5. And the division, of course, is f of x divided by g of x. So for our example, this is going to be 3x squared over square root of x minus 5. So I have f of x is equal to 2x squared plus 1. G of x is equal to 3x minus 5. Now they want us to do a, f composed of g of 2. So this is the f of 3 times 2 minus 5, which is 6 minus 5, or f of 1. And then we plug that in, and we get 3. Right? 2 times 1 squared is 3. B, f of g of x would be f of 3x minus 5, which would be 2 times 3x minus 5 squared plus 1, which would be 2 times, let's see, that would be 9x squared, and then we get 15 doubled minus 30x plus 25 plus 1, which would be distribute 18x squared minus 60x plus 50 plus 1, 18x squared minus 60x plus 51. Now C, what does C say? It says G composed with f of x, so this is the other way around, so this would be g of 2x squared plus 1, which would be 3 times 2x squared plus 1 minus 5, or 6x squared plus 3 minus 5, or 6x squared minus 2. Alright, D, G composed with G. So the little circle right just means G of x. So this would be G of 3x minus 5. And you just plug that in, 3x minus 5. And minus 5 is going to give you 9x minus 15 minus 5, or 9x minus 20. Alright, and then the last one, f composed with f of 2 minus 2. So we get f of 2 times minus 2 squared plus 1, which would be, what's that, 4 times 2 is 8, plus 1 is 9. So this would be 2 times 9 squared plus 1, which is 2 times 81 plus 1, or 162 plus 1 is 163. Alright, so this one, what I'm going to do is I'm going to make up my own functions. So let's say I have g of x, which is in red, and I have f of x, which is in green. Alright, and say I want to do something like f plus g of 2. Right, so this would be f of 2 plus g of 2. Now, how do I get those? I read them off the graph, right? I go to 2. F of 2 is negative 2 plus g of 2, which is 0. Add those together, I get negative 2. If I have f minus g of, say, negative 3, right, that would be f of negative 3 minus g of negative 3. F of negative 3 would be 1 minus g of negative 3, which is negative 3. So that would give me 4, like that. Alright, if I have, say, something like f times g of, say, I don't know, 0, this would be f of 0 times g of 0. F of 0, go to the green one, that's 3. G, that's the red one, times 1, that's 3. Okay. If I have f divided by g of 3, say, this would be f of 3 divided by g of 3. F of 3 is negative 1. G of 3 is 2, so I get negative 1/2, like that. Now if I do a composition, say f composed with g of, I don't know, negative 2, so I get f of g of negative 2, which would be f of, so you go first g of negative 2, which would be negative 1, and then you go f of negative 1, which would be 2. Like that. Alright, if I go the other way, say I have g of f of negative 2, so that would be g of f of negative 2. So f of negative 2 is 0. G of 0 is 1. Like that. Now I could even do something like f composed with f of 0. So this would be f of 0. F of 0 is 3. And f of 3 is negative 1. Like that. Okay, so I'm using the x and y values off the graphs to tell me. So these, whatever goes in, that's your x, right? That's a y, and that's a y. This y becomes the x for the other one. Here you have your x's are the 2's and your y values. So you're adding y values, you're subtracting y values, you're multiplying y values, you're dividing y values. Here you're taking the y value or x value and then plugging that y value back in to get the next one. So algebra functions. So let's try finding the domain for this composition of function. Right, so we want to find the domain of f composed with g of x. So start with this one. What is the domain of the inside one? Well, I know that x minus 1 has to be bigger than or equal to 0, because that's okay to plug that in. So just add that over and we get x has to be bigger than or equal to 1. Now the key is, whatever comes out of this one has to be able to go into that one. Well, I can't plug 0 into this, so that means that the square root of x minus 1 would have to be equal to, can be equal to 0. So I'm going to follow in the complement and then get rid of it. So square both sides, add 1 over. So I know then that x can't be 1. It has to be this, so it has to be, put these two together. So if I drew this like as a number line, right, this one says here's 1, say this is 0. It would be closed and goes this way. Now this one has to be open and goes both ways. Now it has to be what they have in common, so it would be all of this line. So in other words, our domain of f composed with g is going to be from 1 to infinity, because that's the only part that they have in common. And that would be our domain. Right, for this one, what we want to do is undo it. So they're giving us h of x is equal to cube root of 1 over 2x minus 3. Now, if you're just doing, they tell us this. They say h of x is equal to f of g of x, like this. And they want us to write what would f of x be and what is g of x. Now, sometimes there can be more than one answer, especially in this kind of example, because really, I could even say this is 3 different things. My h of x is equal to, say, k, f, and g of x, because I even see 3 functions going on here. So we'll save this one, and we'll do it our own way, and I'll show you why that works. So here we could have, I could have this one as my inside, that's the g, and then this piece, that's the f. So my f would be cube root of x, and my g is 1 over 2x minus 3. If I compose those together, f composed with g of x, I have f of 1 over 2x minus 3, and I plug that in here, and I get what I'm, right, something like that, which is what we have. I could have done it, because there's really several ways of doing this. I could have said my f was f cubed over this, and then my g of x is just 2x minus 3. Again, I'm going to get the same thing I have here. So what I see really here is 3 functions. K, the outside one, that would be the cube root of x. The next one, which would be the f, that would be 1 over x. And then g, which is 2x minus 3. So then you could have, if our h of x would be plug this one into that one, and then plug that whole thing into that one, and of course we do get exactly what we started with. So really we can kind of see that there's 3 things there.